E-Chemistry class presented by Fatima Convent High School, myself Dipali. Chapter 2 Is Matter Around Us Pure? Class 9th. We start with this chapter. How do we judge whether milk, ghee, butter, salt, spice, minerals, water or juice that we buy from the market are pure? We know nowadays lots of adulteration, lots of cheating is done regarding the food products. Then how do we know whether the given product to us is pure or not? Because we all know that these products are matter. Have you ever noticed the word pure written on the packet of these consumables? For a common person, pure means having no adulteration. But for a scientist, all these things are actually mixtures of different substances and hence not pure. For milk is actually a mixture of water, fats, proteins, etc. When a scientist says that something is pure, it means that all the constituent particles of that substance are the same in their chemical nature. So, according to scientific definition of pure, the substances which have same type of constituent particles with same chemical nature is pure. So, pure substance consists of single type of particles. In other words, a substance is pure single form of matter. As we look around, we can see that most of the matter around us consists of mixtures of two or more pure components. For example, seawater, minerals, soil, etc. are all mixture. Now you understand the difference between pure substance and a mixture. Now what is a mixture? Mixture are constituents by more than one kind of pure matter. We know that dissolved sodium chloride, that is NaCl, sodium plus chloride, can be separated from water by physical processes of evaporation. So we know that we can separate NaCl from water, that is seawater. By just evaporating, and we know that what will be left behind in the container will be NaCl and water, that is H2O, will evaporate into the atmosphere. However, sodium chloride is itself a pure substance and cannot be separated by physical process into its chemical constituent, that is Na plus Cl cannot be separated just by physical process. Similarly, sugar is a substance which contains only one kind of pure matter and its composition is same throughout. Soft drinks and soil are not single pure substances. Whatever the source of pure substance may be, it will always have the same characteristic properties. Therefore, we say that a mixture contains more than one pure substances. So, do you understand what is the difference between pure substance and a mixture? A pure substance has only same type of constituent particles, whereas mixture has different types of constituent particles put together without losing their original chemical properties. So, now let us see which are the different types of mixtures. Depending upon the nature of components that form a mixture, we can have different types of mixture. Let us perform an activity. Let us divide the class into four groups A, B, C and D. Group A takes a beaker containing 50 ml of water and one spatula full of copper sulfate solution, which is blue in color. Group B takes 50 ml of water and 2 spatula full of copper sulfate powder in a beaker. Group C and D can take different amount of copper sulfate and potassium permanganate or common salt sodium chloride and mix the given components to form a mixture. Report the observation on the uniformity in color and texture. Group A and B have obtained a mixture which has a uniform composition throughout, but such a mixture are called homogeneous mixtures or homogeneous solutions. Some other examples of such mixtures are salt dissolved in water and sugar dissolved in water. Compare the color of solution of the groups. Though both the groups have obtained copper sulfate solution, but the intensity of the color of the solution is different. This shows that homogeneous mixture can have variable composition. Now group C and D have obtained mixture which contains physically distinct parts and have non-uniform composition. Such mixtures are called as heterogeneous mixtures. Mixture of sodium chloride and iron filling, salt and sulfur, and oil and water are examples of homogeneous mixtures. Let us perform one more activity. Let us again divide the class into 4 groups A, B, C and D. Distribute the following samples to each group. Few crystals of copper sulfate to group A, 1 spatula full of copper sulfate to B, chalk powder or wheat flour to C, and few drops of milk or ink to group D. Each group should add the given sample in water and stir properly using a glass rod. After the particles in the mixture visible, direct a beam of light from a torch through the beaker containing the mixture and observe that from the front was the path of the beam of light visible. Leave the mixture undisturbed for a few minutes and set up the filtration apparatus in the meantime. Is the mixture stable or do the particles begin to settle after some time? Filter the mixture. Is there any residue on the filter paper? Discuss the result and form an opinion. Group A and B have got a solution. Group C has a suspension and Group D has got a colloidal solution. So, you can observe what is happening here. Now, let us understand this. Now, we shall learn about solution, suspension and colloidal solution in the following section. Now, so we can understand very simple flow chart about the substances. If I say matter, then what is matter? We have studied what is matter in the previous chapter, that is, matter is made up of particles. Now, this matter can be divided into 2 groups, that is, pure and mixture. If all the constituent particles are chemically same in nature, it is called pure. And if all the particles are different, in chemical nature, then they are called as mixture. Now, this mixture is again of 2 types, homo and heterogeneous. Homo means uniform or same. And hetero means non-uniform or not same. Now, if the particles mixed together are same, equally distributed all over, then it is called as homogeneous mixture, and if it is not distributed all over equally, then it is known as heterogeneous mixture. Here we can take an example of salt water or salt solution. When you mix salt or sugar in this water, it gets mixed up completely. Every sip of salt or sugar water will be tasting same. But if you take an example of sand and you mix the sand in water, then you will see that the sand particles float. The sand particles float or for some time, and then they will settle down, or they will be moving around in the soil, in the water. So we can say that heterogeneous means non-uniform mixing of the particles in the solution. So this is what we understand by heterogeneous mixture and homogeneous mixture. In activity 1, we understood that when the substances like copper sulfate powder, CuSO4, is mixed in water, then what is happening? It mixes evenly throughout the solution and we see even color of it all over. That is showing us that it is a homogeneous mixture. Same way, if we take potassium permanganate in common salt, then that also mixes evenly all over. But if we take other substances, that is group C and group D had taken, we know that what group C and group D had taken was a different amount of substances, and we mix that together, we find it to be a heterogeneous mixture. Like if you mix sodium chloride and iron filling, salt and sulfur, oil and water, these all are heterogeneous mixtures. Now if we try to compare again further, then the homogeneous mixtures and the heterogeneous mixtures can be further classified. The heterogeneous mixture can be further classified into suspension and colloidal solution. Before that, let us understand what is solution. A solution is a homogeneous mixture of two or more substances. We come across various types of solution in our daily life, like laminate, soda water, etc. are all examples of solution. Usually we think of a solution as a liquid that contains either a solid, liquid or gas dissolved in it. But we can also have solid solution, that is an alloy, that is a solid mixed with solid. A gaseous solution, air, gas mixed with gas. In a solution, there is homogeneity as at the particle level. For example, laminate tastes the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. Now let us see what is an alloy. Alloy are mixtures of two or more metals or a metal and a non-metal and cannot be separated into their components by physical methods. But still an alloy is considered as a mixture because it shows the property of its constituent and can have variable compositions. For example, brass is a mixture of approximately 30% zinc and 70% copper. So, alloy is a mixture. A solution has a solvent and a solute as its component. The component of solution that dissolved the other component in it, usually the component present in larger amount, is called as solvent. and the component of the solution that is dissolved in the solvent, usually present in lesser quantity, is known as solute. So, we can say that a solution is equal to solvent plus solute. Now, let us take some examples of these. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is solute and water is solvent. A solution of iodine in alcohol known as tincture iodine has iodine solid as a solute and alcohol liquid as a solvent. Aerated drinks like soda water, etc. are gas in liquid solution. These contain carbon dioxide gas as solute and water liquid as solvent. The air is a mixture of gas and gas. Air is a homogeneous mixture of a number of gases. Its two main constituents are oxygen and nitrogen, 78% nitrogen and 21% oxygen. The other gases are present in very small quantities. So, are you very clear what is a solution and what are the examples of different solution? Now, let us see the properties of a solution. A solution is a homogeneous mixture. The particles of solution are smaller than 1 nanometer, that is 10 raised to minus 9 meter in diameter, so they cannot be seen by naked eyes. Because of very small particle size, they cannot scatter a beam of light passing through the solution. So, the path of light is not visible in the solution. The solute particles cannot be separated from the mixture by the process of filtration. The solute particles do not settle down when left undisturbed, that is, the solution is stable. So, these are the examples of the solution and properties of a solution or a homogeneous solution. I hope this concept is clear. Let us quickly recap what we studied. That is matter around us pure? What is matter? The particles around us are termed as matter, and this matter is pure. According to the scientific knowledge, the definition of pure is different than the normal pure word which we use for pure ghee, pure salt, pure milk. So, we understand pure means when same type of particles are present in the substance, it is a pure substance. And if different kinds of particles are present in the substance, then it is called as mixture. Mixtures are mainly of two types, homogeneous and heterogeneous. When all the particles are evenly distributed throughout the mixture, it is called homogeneous, and if all the particles are not evenly distributed throughout the mixture, it is heterogeneous. Now, then we have to understand what is a solution. A solution is a homogeneous mixture when two or more substances are mixed and they are distributed equally. This solution examples are given as sugar solution, salt solution, tincture iodine, soda and water solution, and gas to gas, that is the air. The properties of solution are also very clear to you. Thank you for now. We shall continue with the next topic in the next lecture.